The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so there's still people that are confused about what you're supposed to do in terms of test questions and what to send me. So I will again go over that so you'll know for the next test. So when you take the test, if you get an answer correct, you don't need to email me your work. If you get the answer incorrect and you want me to perhaps give you partial credit, email me the work that you used to get that wrong answer. Take a scan of it or a picture of it, whatever, and email it to my school email address. You don't need to attach it to WebAssign. You don't need to type it into the WebAssign stuff. That takes far too long to do it that way. Just email me the work if you want me to consider partial credit. Also, don't go back and correct it and send me the corrected version. Not even going to look at it. I just want to see you got a wrong answer. What did you do? Do you deserve some partial credit for it? Okay. If you still have questions about that, please email me before the next test for me to clarify it with you personally. Having said all that, we're going to go on to a new chapter. We're going to look at chapter 8, section 2. We'll be spending 2 days on this. So this is 8.2 part 1. Okay. Let's say we had a group of individuals. So people. How about Tom, Jose, Mary, and Ralph, okay? And birthdays. Tom's birthday is August 11th. Jose's birthday is June 3rd. Mary's birthday is also August 11th, and Ralph's birthday is October 16th. Okay, so what we have here is a situation where each person has exactly one birthday. More than one person can have the same birthday, but one person can't have more than one birthday, discounting religious experiences, of course. This is the real world, right? Well, this also is how something called a function behaves mathematically. And in a function, we have input and output. The input is called the domain, and the output is called the range. Let me read to you from the textbook what it says about a function. It says a function is a set of ordered pairs in which to each first component there corresponds exactly one second component. In other words, each person has exactly one birthday. The set of first components is called the domain, and the set of second components is called the range of the function. All right. Let me give you some more examples, but using numbers. So let's say the domain, we have the values 2, 4, 6, and 8. And in the range, we have the values 5, 7, 12. And okay, let's say 2 goes to 5, 4 goes to 7, 6 goes to 12, and 8 goes to 7. So each value of the domain goes to exactly one value of the range. Again, we can have 2 values in the domain going to exactly the same value in the range. Each value in the domain goes to exactly one value in the range. Let's take a look at an example where it is not a function. Let's say the domain is 2, 3, 5, and 10, and the range is 7, 4, 8, and 16. Let's say 2 goes to 7, and 2 goes to 4, and 3 goes to 4, and 5 goes to 8, and 10 goes to 16. Because 2 goes to both 7 and to 4, one input goes to more than one output, one domain value goes to more than one range value. This is not a function. All right. Now let's look at some more examples of functions and things that are not functions. Okay. Let's see here. So here I have a list of some ordered pairs. And it says find the domain and range of each relation. Okay, so the domain would be the input, which would be -1, oh, let's see, -5, excuse me, -1, 7, and 8. Notice I'm listing them from smallest to largest, okay? The range would be -6, -1, and 3. And you might look at this and say, well, the domain is just the X values and the range is just the Y values, to which I would respond, yes. Okay. Let's see here. Let's take a look at another example. $10, $20, $30, $20, $40, $60. 10 goes to 20, 20 goes to 40, and 30 goes to 60. Okay, determine whether the relation defines y as a function of x. So this is x, this is y, input, output. If it does not, find two ordered pairs where more than one value of y corresponds to a single value of x. Okay, so yes, this is a function. Let's look at another example, however. Let's see, -4, -2, 0, and 6, 8, 10, 12. -4 goes to 6, -2 goes to 8, 0 goes to 10, and 0 goes to 12. So no, this is not a function, and here are two ordered pairs to show that. 0 goes to 10, and 0 goes to 12. So an input goes to more than one output. That is not a function. Okay. Let's see here. Let's look at some more vocabulary. Domain, range, input, output, X, Y. Let's see. Independent variable and dependent. Can't spell worth a darn here this morning. Dependent variable. Cause, effect. All right, now, typically we refer to domain and range or input and output, X and Y, but also the input, the domain, the X value is the independent variable. The output, the Y value, the range is dependent upon the input. So it's the dependent variable. Another one would be cause and effect, okay? The cause is the input, the effect is the output. So yesterday was a nice day outside. Did any of you wear a heavy wool coat or a heavy winter parka outside yesterday? Anybody? No. You probably wore something for warm weather, right? So the cause was the warm weather. The effect was what you wore, not the other way around. If you put on swimming trunks and walked outside in the snow, would it immediately change to be sunny weather? No. What you wear does not control the weather. The weather controls what you wear. So the weather would be the cause. What you would wear would be the effect, or the domain and range, input, output. Okay, let's take a look at some more examples. How about this? So here we have a table of ordered pairs. 1, 2, 3, 4, 5, 1. So is this a table representing a function or not? The answer is yes. You've got 5 inputs, each one going to exactly one output. They're all going to the same output, but it's still a function. It'd be like having, let's see, is it, well, 5 people with the same birthday. Is that quintuplets? I'm not sure. But anyway, that would be a function. On the other hand, a table like this, oops, let's see, -4, 6, -1, 0, 0, -3, 2, 4, and -1, 2. Let's see here. This is not a function. Why not? Because of those 2 ordered pairs, you've got -1 going to 0 and -1 going to 2. So you've got 1 input going to 2 different outputs. That is still a relationship. You could still represent some equation, a graph, all of that, but it's not a function. All right, now, there is special notation that we use to illustrate that an equation is a function. For example, if we have y equals 2x plus 3, that is an equation, and it also is a function. Let's make a table, and let's see here. Let's take -2, -1, 0, 1, and 2. All right. If x is -2, y would be 2 times -2 plus 3, which is -4 plus 3, which is -1. You okay with that? Any questions there? I'm just completing ordered pairs. Okay. If x is -1, 2 times -1 plus 3, -2 plus 3 is 1. If x is 0, 2 times 0 plus 3 is 3. 2 times 1 plus 3 is 5. 2 times 2 plus 3 is 7. Okay, so we've got these ordered pairs. And we can start to see that for each input, we're having exactly one output. If I wanted to tell the world that that was a function, I'm going to replace the variable y with this symbol. Now, this symbol, it's sort of an italicized F and then a set of parentheses with an X inside of it. And the way we would say that is we would say F is a function of X. Okay, that symbol is just a replacement for Y, but it's used to declare that this equation is also a function. Now, there's a problem with this symbol, that it gets misinterpreted. And that is because we have learned that if you have something next to a set of parentheses, that tends to mean multiplication. So this looks like F times X. We've also learned that the word of sometimes becomes multiplication. Think back to if you happen to take Math 75 and you were dealing with percentage statements. What is 3% of 10? So that would be 0.03 times 10. So the word of could be interpreted as multiplication. And we call this F of X. So it sounds like multiplication. It looks like multiplication, but it's not multiplication. It is a single symbol that replaces Y. Okay, so we'd say F of X. Now, let's go back here and take a look again at this. F of X equals 2x plus 3. We are going to find the same information we found with the equation, but using function notation. So the input for the first ordered pair over here is -2. So the way I would write that using function notation is I would say f of -2 equals, okay? So in general, it's f of x, but specifically, it's f of -2. Now, how do I determine what f of -2 is? The same way I came up with the y values over here. I take -2 and I put it into the right side, and so I get f of -2 equals -1. That is equivalent to this in a table, and it's equivalent to that ordered pair. Any questions about that example? All right. So further examples, if we wanted to find, let's see, f of -1, f of -1 would be 2 times -1 plus 3, which is 1. F of 0 would equal 3. F of 1 would equal 5. F of 2 would equal 7. I'm just using those outputs because it's the same calculation. It's just that you write it using function notation as opposed to a table or ordered pairs. Okay? Any questions about that? Okay. Here we have a function, f of x equals 3x minus 5. We are to find f of 3 and f of -1. So to find f of 3, we put 3 in the place of x in the function. So f of 3 equals 4. Again, that corresponds to the ordered pair 3, 4. This is how we would write it in ordinary equation notation. This is how we write the same thing in function notation. F of -1 would be 3 times -1 minus 5, which is -3 minus 5, or -8. So f of -1 equals -8, which corresponds to the ordered pair -1, -8. In fact, if we were to plot this on a graph, it would be the same point. Let's see, -1, -8. It would be the same point whether we plotted it using function notation or equation notation. All right. So the graph of this function would look just like the graph of y equals 3x minus 5. Okay. Let's say we've got g of x equals x squared minus 2. Whoa, hold on there. What do you mean g of x? Okay, just like our variables are not limited to x and y, function notation is not limited to f of x. We can pretty much use any letters we want. In fact, let's say that this was Math 111. It was a business algebra class. In that class, we might talk about a cost function, c of x, a revenue function, r of x, a profit function, p of x. So anything goes in terms of variables. It's not just limited to f of x. All right, back to our example. G of x equals x squared minus 2. We are to find g of 2 and g of 3. So g of 2 would become 2 squared minus 2, which is 4 minus 2, which is 2. So g of 2 equals 2. G of 3 would be 3 squared minus 2, which is 9 minus 2, which is 7. So g of 3 equals 7. All righty. Again, any question on those examples? Okay, we'll continue then. Let's say I've got h of x equals x divided by x squared plus 2. And I'm going to find h of 5 and h of -2. So h of 5 would be 5 divided by 5 squared plus 2, which is 5 divided by 25 plus 2, or 5 divided by 27. H of negative 2 would be negative 2 divided by negative 2, the quantity squared. Notice the negative sign is inside the square, plus 2, which is negative 2 over 4 plus 2, negative 2 over 6, which reduces down to negative 1/3. Another example, h of x equals x squared plus x minus 2 all over x squared minus 5x. And we are going to find h of 5 and h of negative 2. So h of 5 would be 5 squared plus 5 minus 2 over 5 squared minus 5 times 5, which is 25 plus 5 minus 2, which is 30 minus 2, which is 28, over 25 minus 25, which is 0. Well, any non-zero number, such as 28, divided by 0 is undefined. Okay? Any questions about that? H of negative 2 is negative 2 squared, plus negative 2 minus 2, all over negative 2 squared minus 5 times negative 2. Which is 4 minus 4, which is 0 over 4 plus 10, 14, and 0 divided by a non-zero number is 0. Now, I want to talk ever so briefly about this scenario, because when 5 was an input into this function, we got undefined. We didn't get a real answer. 5 is not in the domain of H. It is not an acceptable input. If we put something in and we don't get something real out, then that input is not valid. We say it's not in the domain. We'll talk more about that later. Okay, let's see here. Now, we have the following function, g of x equals 2x. We are to find g of w and g of w plus 1. Keep in mind, whatever is on the inside here goes on the inside there, and also everywhere to the right that has that same variable x in this case. So g of w would just be 2w. Okay. G of w plus 1, we're going to replace x with w plus 1. So this would be 2 times w plus 1. And in this case, we would distribute to get 2w plus 2. Okay. Let's take that a little bit further. Let's say again, we've got g of x equals 2x. What would g of star equal? Well, that would be 2 times star. How about g of Barbie? G of Barbie would be 2 times Barbie. How about g of Ken? That would be 2 times Ken. G of cat would be 2 times cat. G of whatever would be 2 times whatever. Okay, so whatever you'd put in there, you'd take 2 times that input. All right, so don't make it more difficult than it is. Don't create some magical universe. It's just substitution. All right, what about this? G of x equals 2x minus 7. G of w would be 2w minus 7. G of W plus 1 would be 2 times the quantity W plus 1 minus 7, which is 2W plus 2 minus 7, which is 2W minus 5. So again, what are we doing? We're putting this in the place of X. Whatever is on the inside becomes the input, and the result is the output. Okay, let's see here. Now, let's say that f of x equals negative 2x plus 5, okay? For what value of x does function f have the given value, and that is f of x equals 5. So this is kind of like Jeopardy, where we have the answer, but what's the question? We have the output, but what's the input? What value of x put into the function would give us 5 as an output? Recall that f of x is another name for y, okay? So what we're going to do is we're going to take this 5 and put it in the place of f of x, and then solve for x. All right, I'll subtract 5 from both sides. I'll divide both sides by negative 2. So for what value of x is f of x equal to 5? For x equals 0. In other words, f of 0 equals 5. Well, does it? Let's see. F of 0 would be negative 2 times 0 plus 5, which is 5. Yes. So the output is 5. What's the input? 0. That's like saying we have an ordered pair. We know the y value is 5. What's the x value? So you take the y value, put it in the place of y, or f of x, same thing, to find out what x is. Okay, let's do another one of those. Let f of x equal 3/2 x minus 2. For what value of x does function f have the given value? And we have f of x equals 2/3. So now we're going to put 2/3 in the place of f of x. So we've got 2/3 equals 3/2 x minus 2. Solve for x. Well, let's see. We could clear the fractions by multiplying both sides by the least common denominator, which is a 6. 6 times 2/3 would be 12/3 or 4. 6 times 3/2 x minus 6 times 2, we'd have what, 18/2 or 9x minus 12. Add 12 to both sides, 16 equals 9x. Divide by 9, x equals 16/9. So when the output is 2/3, the input is 16/9. Did I lose anybody there on that example? Do I need to go back through anything there? We're okay. All right.
Could you go back through it slower, please?
I absolutely will. Okay. Let's go back here. We've got f of x equals 3/2 x minus 2. And we want to know for what value of x does f of x equal 2/3. So it's like we're completing the ordered pair, x comma 2/3. What is the x value? Again, let me remind you that f of x is another name for y. So all of this goes over here and replaces f of x or y. So now we've got 2/3 equals 3/2 x minus 2. Are you okay up to there?
Yes.
Okay. So now I want to clear the fractions of this equation. And to do that, you multiply both sides by the least common denominator, which is 6. You okay where I'm getting the 6 from?
Yeah.
Okay, so I'm going to multiply this side by 6 and that side by 6. So I'm going to get 6 times 2/3 equals 6 times 3/2 x minus 6 times 2. So that's distributing the 6. All right there.
Yeah.
Then we'll go through and reduce it. 6/3 is 2/1. 2 times 2 is 4. 6/2 is 3/1. 3 times 3x is 9x. And 6 times 2 is 12. So now I've gotten rid of the fractions. To solve for x, I'm going to add 12 to both sides of the equation. 16 equals 9x. Then I'll divide both sides by 9, so x equals 16/9, which does not reduce. So basically f of 16/9 equals 2/3. Okay with that?
I guess I'm trying to do this fraction math and figure that out.
You're trying to do what?
The fraction math.
The fraction math. So instead of clearing the fractions, you're trying to just deal with them?
No, I guess I'm just trying to follow along of how you did that.
Okay. Did I lose you here?
Yeah.
Okay. All right.
Cool. So now I have both goats I've previously seen, theoretically. They're null right now, but
Okay.
next round they'll be goats in that array. And I'm gonna say that I need to now choose my left goat.
Okay.
And-
So I've just rewritten that like this. Okay, so that's distributing. Now, this is like 6/1, 6/1, 6/1, 2/1. Those are implied denominators.
If something
I could take this and make it,
array, does anybody
you might want to, yeah, block your voice so whoever's there isn't, because this is going to be on YouTube later and they may not want their voice on YouTube. All right, so 6 times 2/3. We could write that as 12/3 and reduce it down to 4. And there's nothing wrong with that. But I'm going to pre-reduce it and say 6/3 is 2/1. So now I've got 2 times 2/1, which is 4. Are you okay with what I did there?
Yeah.
Okay. Next product. I'm going to take 6/2 and reduce it to 3/1. So now I've got 3 times 3 is 9 times x is 9x over 1, or just 9x. And then
Yeah.
minus 6 times 2 is minus 12. All right with that?
left?
Yeah,
is
thank you.
equal?
Oh, you betcha. So then we'll add 12. 16 equals 9x. Divide by 9. 16/9 equals x. All right. So that's all I've got for you today. Section 8.2, the first part. Tomorrow we'll wrap up 8.2. And I will be back at 1:15 with an office hour. Many of you wanted to know what your grade was and everything. Well, I haven't corrected the tests yet. I always wait until the next day because some of you didn't finish it till 11:59 last night. So I'll be wrapping that up this afternoon. And then those of you that asked me, I'll be emailing you your grades. Okay, well, have a great day. And if I don't see you this afternoon, I'll see you tomorrow.